So for the next one below, we want to know how likely is it, or how many ways at least we can get only 4 of the cards to be hearts, and then the other card has to be something else. And we'll find the probability of that. So here we want the probability we only get 4 cards that are hearts. Okay. In other words, we want to know, if you're playing poker or whatever, and you're getting a deal of 5 cards. Again, we don't care about the order. It's without replacement. Stop sharing. Here I come. That's weird. Stop sharing. That's annoying. Let me see. I should do it. Okay, good. Sorry about that. What happened? All right. Anyway, so what we have here is, we have a deal of 5 cards. We want to know the probability that only 4 of the cards are going to be hearts. Okay. Let me draw. So 1, 2, 3, 4, 5, right? Only 4 of the cards are going to be hearts. Again, the order doesn't matter. So let's just say it's the first 4. Okay. Well, for the 4, we know as really up here, there are 13 hearts in the deck, right? 13 hearts in the deck. And we want 4 of them. Not caring about order and without replacement, we have this. Right? There are 13 cards that are hearts. We want 4 of them. So we want to choose 4 of them without order, without replacement. So it's a combination. So because of that, we have C of 13, 4. But are we done? Well, you can see from the slide, we're not, because we have to handle the last card. Right? We don't want this last card to be a heart. This has to be something that's not a heart. How do we handle that? Well, if there are 13 cards that are hearts, there are 39 cards that are not hearts. I did this because we have the 3 other suits. Right? We have spades, clubs, and what's the other one? Diamonds. 13 cards in each suit. So that's 39 possibilities for the last card. So for the last card to handle that, we have 39 possibilities here. So let me see if I can draw it. C of 13, comma, 4. And here we have 39 possibilities. For the last card, well, again, by the basic counting rule, we multiply. We're multiplying. Right, to figure out what's going on, the first task would be choosing the 4 cards that are hearts, and then the next task would be handling the last card. So we would have to multiply. That's what we're doing here. A little bit of repetition here, but that's okay. So again, this is what I wrote down here. The first 4 cards to handle that. That's C of 13, 4. That's our first task. For the second one, for the last card, the 5th one, we have 39. That's how many cards that are not hearts. So we multiply that. Then we divide by C of 52, 5 because we want probability. Okay. All right, so we have that example. Okay, I think that's it for that. I'll keep it. All right, so because of that, I really wanted to try a worksheet, but I'm afraid to because I didn't go through it first. Well, I guess we'll just have to do chapter 10 then. So, okay, that's cool. Right, so let me get that going. Letting it load. Oh, there it is. Good, good. Okay. So this is chapter 10, so there's not too much to it. We don't have much time left anyway, so I guess we're doing good. So in chapter 10, what we're going to work with is statistics. Basically, statistics is used almost everywhere you go. The idea with statistics is you're gathering information, you're analyzing it. You're also going to make predictions somehow, and present your data as well through, charts, graphs, things like that. And in fact, in statistics, we get to analyze groups of people. You may have a question, for instance, about what do all the students in SUNY Oneonta think of, I don't know, policy A. I don't know what policy A is. I just made it up. But what you can do is you can analyze different groups of them. And then from the groups, from the data, you can make a prediction. And that's usually what happens in statistics. There is probability in statistics. Just letting you know. I'm not sure how much we'll see, but there is probability in statistics. But here I'm just saying what we're going to see in this chapter. In the first, the first section, which I basically almost did, we'll see like a lot of vocabulary. Like what is a location, what is a sample, things like that. Briefly, you'll see a population. It's just a group of people you're studying. And usually what's going to happen is with a population, it's going to be so big, population. It's not going to be like 10 or 20 people. It could be thousands or even a lot more. I think SUNY Oneonta has at least 1,000 students. A lot more than that, I think. So generally what we want to do to save time and money is to work with what's called a sample. And of course, we have to wonder, okay, well, how do you choose the right sample? That's where sampling methods come into play. Mostly because you want samples to really represent the population. We'll see how things can go wrong. There's the idea of bias. There's the idea of like samples not representing the population. We'll see a little bit of experiments and observational studies. There is a difference. Then we'll see a little bit about presenting data. Again, just like before, whatever I skip, you don't have to know. I'm really hoping to get up to chapter 12. We'll see what happens. All right. So we have that. So again, like I just said, what we like to do in statistics, we like to study groups of people. We might wonder, what do all New York residents think of our president, Donald Trump, for instance, right? Or what do they all think about our governor, Cuomo? Hope I said his name right. Do they all like how he's handling this pandemic? You know what I'm saying? We like to wonder about that. So we like to somehow get that data. So there, our population, the group of people we're dealing with, would be all New York residents. So our population is the population of some kind of study, which I guess you can almost think of as like an experiment. Well, I wouldn't say it's an experiment, but the population you're analyzing, it's the group of people or objects or whatever you're collecting data from. It doesn't have to be people, I don't think. Pretty sure it doesn't. But that's basically what it is. It's the entire group you're dealing with in a statistical study. I said one example, but here's another one. This one I just kind of made up. We might wonder how many hours of reading a week does a typical college student at SUNY Oneonta do? So our population there could be all SUNY Oneonta students. So that's what our population would be. You have to be careful, though, in that you have to be specific about who the population is. For instance, you might get very different answers depending on what group of students you ask. I don't know much about other majors, because I took like only basic college classes years ago when I was a college student. I'm pretty confident some majors have a lot more reading than math does. So for instance, if you were to ask only college students who are majoring in fields, the humanities fields like philosophy, or what's another one, or sociology, I think that's humanities, history, things like that, you're probably going to get very different answers in the amount of reading done per week than just asking physics, math majors, for instance. If we, like even as I wrote down there, you want to be careful about which college you're dealing with, I mean, here I'm saying SUNY Oneonta students, but if I said a different college, say, I don't know, like Harvard or something, I would think the answers are going to be pretty darn different. So, every college is different, for instance. But you do have to be specific with the population that you're dealing with. Otherwise, your answers could be very, very different. That's what I'm trying to say here. What the? Oh, here we go. And this is just some other kind of terminology. Basically, from your population, you're going to calculate certain data, and that's what parameters are. You might look, for instance, I mean, I hate to use this word now, but you might look, for instance, the average amount of reading per week that SUNY Oneonta college student does per week. Parameters are values dealing with the populations that you calculate, like the total amount of hours per week that a college student reads, SUNY Oneonta college student reads. Now you can get that data using a census. I'm saying that right, which is a survey of the entire population. So this is an example parameter. We could use a census to do that, a survey that is. I mean, with computers and stuff, we can probably just send it out by email. Although that'd be kind of sending out a census would be kind of tricky, mostly because not everyone's going to have to answer. Not everyone will answer it. So basically getting data from every member of a population generally is not what you want to do. Yeah, I don't know off the top of my head how many college students in Oneonta there are. I don't mean in Oneonta. I mean attend SUNY Oneonta. I want to say there's thousands. So generally what we like to do is we like to get a sample. A sample is just a subset, basically, of the population. But as I wrote here, it has to be representative. So you can't just choose people. You got to be careful the way you form your sample. I mean, going back to that reading idea, if we were to ask only college students who were majoring in a humanities field, right, that wouldn't be representative of the entire SUNY Oneonta student population. Not every student majors in a humanities field. So you do have to be careful when forming your sample. And then statistic, that's just that's kind of like a parameter, but instead of for the population, it's only for the sample. Did I get the I got the definitions off. I think a statistic should be for a sample. I'll have to double check this. So sorry about that. So, and there's different methods we can actually form. And again, you want to make sure your sample is representative of the population. So again, as you can see, I didn't get very far with chapter 10, but that's okay because we're just starting it today. Today's what, Thursday?